Hey guys, in this tutorial we'll be solving the problem word ladder 1, which is on InterviewBit. So let's get to the question. So basically in this question you'll be given an initial string. So taking this example, the initial string here is hit, and then you'll be given a final string. This example it's cog, and you'll be given a dictionary of words. So basically what you'll have to do is you'll have to find the minimum transformational sequence possible to convert the initial string to the final string, and the condition for a transformation is that the difference in the characters can be maximum 1. So basically from hit to hot is considered a transformation. It's considered a legal transformation because the difference in the characters is just 1. So that is I is being converted to O. But hit to dot is not a correct transformation, and it is not allowed because there are two characters that are being changed, that is D, and H and I are being converted to D and O, so that's not allowed. And all the words that are chosen for the transformation must be in this dictionary. So yeah, that's what these two conditions state. So I guess you've got, guys, so taking this example, you'll see that you'll need a minimum length of 5 to convert hit to cog. That is, from hit you'll have to go to hot, and then from hot you'll have to go to dot, and then from dot you'll have to go to dog, and from dog you'll have to go to cog, which is our final string. And you can see that the between every transformation the maximum difference in the characters is just 1. So yeah, so that's what the question is, and let's go ahead and check how we can solve this question. So yeah, this is the same example that's given on InterviewBit. That's the initial string, the final string, and the dictionary of strings, or here you can say a list of strings. So yeah, now representing it in a graph form, how you can convert the initial string to the final string, we get something like this. That is, hit can be transformed to hot, hot can be transformed to either dot or lot, dot can be transformed to dog, lot can be transformed to log, and dog and log can be transformed to cog, which is a final element. Here basically cog is supposed to be one node in an actual graph, but I've represented here as two different nodes. But in an actual graph, cog would be just one node, and dog and log would be connected to cog. So this is the graph mentioned. This is the graph that we would get by considering the path from the initial string to the final string. Now what we're supposed to do is supposed to find the minimum length that is possible to convert the initial string to the final string. So we can it'll be converting smallest path from our starting node to our final node. Our final node here being cog. We know that given a graph we can find the smallest path. We can find the smallest path from the from any node to another node in a graph using BFS, or breadth first search. So that's exactly what we'll be using here. We'll be using BFS to find the smallest path length from the initial string to the final string, which is hit and cog here respectively. So yeah, so to do so we'll need basically two queues. The first queue would be for storing the indexes of the strings that are present in the queue currently, and then the second queue would be to store the to store the number of moves that are required to reach that current string from the initial string. So basically if hot is currently in the queue, then the index 0 would be in the queue, because hot is the 0th element of the string of the dictionary given to us. You can see here that hot is in the 0th position, so the queue would hold 0 when hot is being put into the queue. And we'll also need a boolean, not necessarily boolean, an integer list, which acts as the visited list. Here 0 would indicate that the element or node has not been visited, or the string has not been visited, and 1 would indicate that the string has been visited. Also we'll need a length variable. This length variable will be the minimum possible length of the transformational sequence that transforms the initial string to the final string. And initially we'll assign it to infinity. By infinity I mean the maximum possible value that can be stored in a string. Stored in an integer. So yeah, going ahead with this, what happens is, first we know that we would traverse the entire array, the entire dictionary that is given. First we would traverse the entire dictionary given, and we would find all the strings which differ from the initial string by just one element, by just one character. So in this given array of strings or list of strings, we see that hot is the only element that can be that can be transformed from hit. So basically, hot is the only element that is chosen here. So what we do is we take hot and we insert the index of hot into 0, and we insert the value 2 into moves, because the number of moves required to go from hit to hot is 2. So actually you might say it is just one move, but we consider the initial element. According to the question, we must consider the initial element and the final element. So it's basically actually the number of elements that are in the transformational sequence. So basically hit and hot are part of the transformational sequence, so insert the value 2. And then since hot has been visited, so we mark the value of the index of where the hot is present as 1. Now so what we do now is, we'll have to, once the initial iteration has happened of where we check through the list and check which element only differs by 1 from the initial element. After that, what we have to do is we'll have to go into a while loop where until all the elements, and the only breakpoint of the while loop would be if the queue is empty. The given queue here, the first queue is empty. So basically right now the queue has one element and the moves has one element, so we enter the queue. So, and basically the first thing when we enter the queue is we'll have to poll the first queue, we poll the second queue, we store each of them into variables. Now what we do is we check if the current element that has been polled out based on the index, so we poll out 0 and we check the element as the 0th element, that is hot. Now what we do is we check if the difference between hot and the last element, that is cog is our final element, we check if the difference between the number of characters between hot and cog is just 1. If it is just 1, then what we do is we update the value of length or len. So we update the value of len as the minimum of the current value of len or the element that has been just pulled out. So basically if the difference between hot and cog was just 1, then we would update the value of len to 2, because the minimum of infinity and 2 is 2 obviously. So yeah, this is how this is the initial step of the queue. So since hot and cog are not just one difference away, so what we do, we go ahead in the while loop. So what we do is we insert the elements which are adjacent to hot, that is just one difference away from hot. So here dot and lot are just one difference away from hot, so we insert their indexes into the queue. So basically you can see that dot is at the first element and first index, and lot is at the third index. So that's why we put in 1 and 3 into the queue. So and then we insert the moves as 3, because 3 is the element, 3 is the number of strings that are present in the path from hit to dot so far or hit to lot so far. So and then we mark dot and lot as visited, but since and length remains same as we've not reached the last element. Then we go ahead, we find the adjacent element to dot and the adjacent element to lot, we insert them into queues, we update the moves value by checking the value that's the length of the transformational sequence that is required here. So basically here what we did was we for dot we inserted dog, and we found that the value of dog is the length of the transformational sequence from hit to dog is 4, so we add the value 4. So basically the 2 here is for the dot, the 2 is here for the dot, the value of 2 represents dot and 4 represents dog. Actually you can you can see it, not dot, dog. You can see that value of 2 has been inserted here because dog is at the second positional value, and 4 represents that the length of the string from hit to dog. So yeah, so we can keep going at this way, and that then you will find that at some point you would reach cog. So basically, you will find that at some point when you go to dog, you will find that uh, the difference between the number of characters from the dog and the final element, that is cog, is just one. That is, d is being changed to c. So that is when you'll update the value of length. So you'll update the value of length by checking the minimum of the current value of length. Right now it's infinity, and then when we and then the current element that has been pulled out of or removed from moves. So then it would be 5, because 1 2 3 4 5 we would have reached 5. So the minimum value of the length would be 5. And yeah, this is how you update the length values. And as since when you reach dog, since when you reach cog, when you reach dog, you won't find any element that has been the difference between dog and cog, the difference between dog and any other string would be 1, such that the element is not visited. So basically, since it's not since there's no such element, it won't be appended into the queue, or it won't be added to the queue. And so initially the number of elements would from the queue would turn to be the number of elements in the queue would turn to 0, and we would exit the queue, exit the while loop, that is, and we would return the we would return the value of the variable len. So basically in our case it would be 5, and we would return the value 5. So yeah, you might not have a complete understanding from what I just explained from the pictures, but I think it would be a lot more clearer once we start coding. So yeah, let's get to the coding. So basically I'll be using Java. Okay, so first let's go ahead and code a function that can give us the distance between two strings, that is the number of differences between two strings. So let's take in two strings as a parameter. Let's take so now so what I'm doing is I'm traversing. It is given in the question that the length of all the strings is same, so we won't have to worry about the checking the lengths of both the strings. So if the characters are not similar at the same index, then we increment the difference value, that is d here. Also we increment the pointer, I mean the index, and then we return the difference. Yeah, so this should give us the difference between the two strings. Now, like I said, we would initially initialize the value of len to a maximum value. Let's take in let's assign the value start to string s. Now, like I said, we'll need a visited array to check if the element has been visited or not. In Java, if you assign so this has been C, this would be A, sorry, that, yeah, this is the initial string and this is the final string and this is the dictionary. So I would assign the initial string to S, and then C dot size, sorry. Now yeah, so in Java, if you initialize an array, integer array, all the values of the array would be 0 initially. So yeah, so that would say that all the values are initially unvisited or not visited. So like I mentioned, that we'll need two queues, one to store the indexes of the elements, of the elements currently in the queue, and you'll need another queue to store the length of the transformational sequence to reach that element from the initial element. Now we check if the distance between the initial element and the final element is 0, that is if both the elements are same, then we would return 1 because it would just be one element, that is the starting string. And if the distance between them is 1, that is the difference in characters between them is 1, then we would do, because the sequence would have two elements, that is the initial and final element. And then we would go through do the initial iteration of checking all the elements whose difference from the initial element is just 1. So to do that iteration, you just have the simple for loop. So we check between the start element and the element at the current index. So if it's 1, then we add that element to the queue. We add the index of that element to the queue, and we also add the number of moves to be 2, because it would be the initial element and the element so far. Now we would enter the while loop. Now we first what we do is we first remove the element from the move, finding the number of moves to reach to that element. Then we remove the index of the element from the queue. Then we assign the string value to s. So now if the distance between the initial element and if the current element and the final element is just 1, we would update it like I mentioned by considering the minimum of the two elements, that is len or the element that has just been told. So if that's not the case, then we mark we mark this as visited by marking it as 1. 1 would mean it's visited, and 0 would mean it is not visited yet. Now we would go through the entire all the elements that are connected to this So we check for the among the neighboring elements of the currently chosen node. We check if the neighboring elements are not visited. If they are not visited, then and if the distance between, that is neighboring elements, we find the neighboring elements by checking if the distance between them and the current element is 1. Then that element would be considered the neighboring element, and if it is also not visited, then we would add that element to the queue. So here if the element at index I is a neighboring element, that is the difference between the current element and that is just 1, then we would add it to the queue, and we would increment the length by 1 because it would take one additional step to get to that element from the initial string. So that's what we'd be doing, and so yeah, that would take care of the while loop. Now once the queue is empty, we would come out of the while loop and we check if the final element is still the max value. That means there is no possible solution from the initial element to the final element. So what we do is we return 0. Here it should be moves. Yeah, and if else, if there is a possibility, if there is a path from the initial string to the final string, then the the shortest path from the initial string to the final string would be this. So let me just quickly check if there are any errors, but I can only see so less. So before we go to the testing, we'll just have a brief check. Well, I'm quite confident that there are errors, so yep, like I said. You know what? Oh, I've not put up a equal sign here. Sorry on that. Let's go ahead. There's still got to be errors. Yep. And okay, there's no end. I've misplaced B with end. Sorry on that. Let's check for more errors. Sorry on this. Let's check for more errors. Size. I'm sorry. It should be the size of the element. Why am I doing this? Really sorry. Okay. Okay, there's another error here. It's supposed to be Q and not Q. Sorry. So let's test this now. Okay, compiled fine. Let's submit and see what happens. Okay, it partially solved the question and it's not the most optimal. So yeah, this is what I've got so far, but in case you guys have found a solution which clears the entire solves it in the most optimal manner and finishes it in the given time limit, then yeah, please do share the solution with me. And this is all I've got, so thank you for watching the video. Yeah.